Hey guys, and welcome to this video. In this video, we're going to talk about bearing, and we're going to explain this question again. This question here, Geneva Airport is 140 kilometers from Paris, Orly Airport, on a bearing of 135 degrees. Draw this bearing accurately using a scale of 1 centimeter to 50 kilometers. So basically, the first thing you do, you have to put the point, which is Paris Orly Airport. Let's cover this so we can work here. I just want to explain the ideas here. Okay. So, first thing we do, we put the point of the airport that represents the airport. And as we said, let's say this is the airport over here. And then you draw the north line. So the north line will be like this. So that's the north line. And that's the airport. Let's call it B-O, P-O-A, or Paris Orly Airport. Okay. Now, after doing this, you need to find the 135 degrees angle so you can find the direction of movement. So we're going to go to the maths pad to do this and to find the angle, okay? Now we're going to find the angle, which is 135 using the protractor. First, we take out the protractor. We put the point on the point like this. So point on the point and line on the line like this. So point on point, line on line, we start with the zero on the line. We don't start with the zero that's not on the line. We always start with the zero on the line. Now, here, let's take the pen. So we need 135. So this zero, we start from it. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 135, which is over here. This is the direction that we're going to use to draw the line. Now we will go back to the question, or let's finish the question here. We know that the scale is 1 to 50. So let's go back to the question so we can read it directly. Okay, let me remove the protractor and then do this. Now, after finding the angle, I can label it like this. I can write 135 because I found the direction of the angle. Now, I'm going to find the map distance using the real life distance and the scale that we have. So basically, I just write the scale, which is first I write map here and real life. Okay. And then with the map is 1 centimeter, like this. I write it 1 centimeter. This represents 50 kilometers, 50 kilometers. Now, we understand that the right or the real life distance is 400 kilometers. So we write it under the real life distance, which is here, 400 kilometers. And now we are trying to find the map distance or the map, yes, the map distance of these two airports. So basically, I just put a box to find the map distance. Now I just make sure that they have the same units. And then after making sure that they have the same units, I just cross multiply like this. So 400 multiplied by 1 is going to be 400. And then 400 divided 50, it's going to be 8 centimeters. So this means I'm going to draw a line of 8 centimeters length between these two airports to find the place of the second airport. I'm going to do this using the ruler. So I'm going to take you back to the maths pad. Now I know the length of the line, so I mean I'm going to draw the line here. So first I'm going to bring the ruler here, yes. So the line should be 8 centimeters. This means, it's a little bit down here. I can take them here. I know the direction. I can take these here, yes. And the point over here, yes. So basically, this is the angle, 135, yes. Now this is the ruler. I'm gonna draw an 8 centimeter line that goes through these 2 points. So it's going to be over here. So from here till 8 centimeters, which is over here. And this is how you answer a question like this. Now let's remove the ruler and we can label the line with 8 centimeters like this. 8 centimeters. And we don't have to label this, or we can label it. It's okay. It doesn't matter. Now we're labeling the airport here, and this is how you answer a question like this. So focus on the bearing angle and how to find it, and focus on using the scale and how to use it to find the map distance and drawing the map distance on the map. That's it for this question. Let's move on to the next question. So the next question here is very important. It's about finding the other bearing after they give you one of the bearings. First, let me cover this so I can work here. You don't have to draw the bearings, you just have to find the other bearings. Now, if I look at the question, I'll notice that they gave us one of the bearings. So the first one is 120. They told us that the bearing of B from A is 120. Work out the bearing of A from B. So basically, they were going to give you one bearing and you're going to find the other. If the bearing that they gave you is less than 180, you just have to add 180. If it's more than 180, you have to subtract 180. So let's take a look at the first one. The first one is 120. Because 120 is less than 180, it means I have to add 180 to it. And the answer will be, very good, it's going to be 300 degrees. So the bearing of question A is 300 degrees. Same idea with question B and C. Let's take a look at the bearing they gave us. So the bearing in B is 240. 240. 240 is more than 180. It means I have to subtract. So if it's less, I have to add. If it's more, I have to subtract. So 240 minus 180 to get the other bearing, to get the other bearing. So 240, so here, 240, here, 240 minus 180. And the answer is 60. So the answer is 60. Good. Now the last one, which is C, the bearing that they gave us is 320. 320. Now 320 is more than 180. It means what do we do to it? Very good. We subtract 180 from it to find the other bearing. So 320 minus 180 will give us 140. And this is how you find the other bearing without drawing the bearing or the lines. You just take a look at the angle. If it's less than 180, you add 180 to it. If it's more, you just subtract 180 to it. That's the whole idea. Very good. Now, let's move on to the next question. Next, here. Now here we covered the bearing questions. Let's take a look at 8.3. So in 8.3, we're going to talk about scales and ratios. Scales and ratios and questions about scales and ratios. Let's go down and check the questions. This one is about turning units. It's the same as we talked about. Focus on the units turning because it's very important. You have to understand how to turn units to answer these questions. Now, let's take a look at question 2 because it's very important. Writing a scale in the form of 1 to n. The form 1 to n means what? It means the first number must be 1. And how do you make the first number 1? Very good, by dividing it by itself. So basically here, for this question here, 2 to 10, it means I want the first number as 1. It means I'm going to divide it by itself. Here, let me cover this. So basically 2 to 10 here, I need the first number to become 1. It means I have to divide it by 2. That's the whole idea of 1 to n. And because I divided the first one by 2, I have to divide the second one by 2. Same idea with all ratios here. You divide the first one by 4 and you divide this by 4. You divide by 40, you divide by 40. So the whole idea is making the first ratio 1 by dividing it by itself. So 2 divide 2 is going to be 1. And then 10 divide 2 is going to be 5. So the answer will be 1 to 5. And this is how you answer question 2. Same idea with all of them. You just divide them by the first number. Now let's move on to the next question. Copy and complete equivalent ratios. Equivalent ratios are easy. It means how did the first one or the second one become like the other? For example, here, how did the 1 become 3? Very good, by multiplying by 3. It means even the 100 should be multiplied by 3. So I multiply the 100 by 3 is going to be 300. So the answer is 300. So basically, I check what happened to one of the ratios by multiplying, and then I do the same for the other ratio. Here, the 1 became 4. How did the 1 become 4? Very good, by multiplying by 4. And because I multiplied by 4, I have to multiply 250 by 4. So it's going to be multiplied by 4. So this one will be 1000. Very good. Same idea to all of them. How did the 1 become 5? By multiplying by 5. 30 times 5 is going to be 150. Same here. 1 became 3 by multiplying by 3. So I multiply this by 3 is going to be 1500. So the equivalent ratio idea is checking the ratios and what happened to the ratios and doing the same with the other ratio. Now let's move on to the next question. Now you need to understand that a map ratio or a map scale has numbers like these, and both of them are centimeters. We're going to talk about this and how to turn scales into map scales, okay? Here, both of them are centimeters, so you have to use them the way that they are, okay? Let's take a look at question 4. It's a good question. Let's cover this. We're going to work out one of them and then the others are the same, okay? So first, James is using a map with a scale of 1 to 20,000. So the scale that we have, as we said, we write it like this, map, real life, okay? Now, the map is 1 centimeter. As I said, if there are no units, it means if they are in centimeters. So the map is in centimeters here. And the real life is 20,000 centimeters, like this. Now, to use this, read the rest of the question. What are the distances in real life? What are the distances in real life? This means that they are on the map, they need them in real life, and they want them in meters. So, because they are on the map, I have to write them under the map, like this. So, I'll start with the first one, 4 centimeters. Now, I need to find out the real life one. I'll find out the real life distance by doing or using the cross or the x method, like this. Now I put the x between them. I make sure that the ones on top of each other have the same units. And then I do the x method by multiplying 4 times 20,000 and then dividing by 1. And the answer is 80,000 centimeters. Now the question wants what? They want the answer in meters. So I have to turn these centimeters into meters. To turn centimeters into meters, what should I do? Very good. I should divide by 100 because 1 meter equals 100 centimeters. To turn centimeters from a small unit, I have to divide. So I'm going to say 80,000 divide 100. This. And I'll get the answer in meters. So let's put the fraction line. Dividing means the zeros will go together, two zeros, two zeros. And the answer is 800 meters. 800 meters. And this is how you answer a question like this. So focus on the scale and how to use the scale to answer a question like this. Yes, very good. Yes. Now, the others have the same ideas. You just have to put them here and then find the answer in centimeters and then turn it into meters. Now, the next question here, let's cover this. Okay. Next question here is the same idea. We have the scale We have the centimeter and the kilometer. They need you to match this with these. Now, let me show you how do you turn these into a map scale. This is very important. You have to understand it. And then we will talk about writing these as a map ratio. Same idea. This one and the one down are the same. So basically, let's answer the ones down because they have the same ideas. Let's answer these ones, write these as a map ratio. So to write a scale as a map ratio, I'm going to do one of them and the rest have the same ideas, okay? Basically, you have to turn them all into centimeters because a map ratio is only in centimeters and it has no units. So let's cover these as no units and it has to be 1 to n, okay? So 1 to n and no units. Let's do it like this. So first thing we do, we have to turn them into centimeters. This one is already centimeters. So I'll write it like this. 5 centimeters. Let's make it bigger. Now, 5 centimeters to, this one is 1 kilometer. To turn kilometers into centimeters, focus on this. You have to go through meters, turn it into meters, and then turn the meters into centimeters. We know that 1 kilometer equals 1,000 meters, okay? And 1 meter equals 100 centimeters. So to turn a kilometer into centimeter, I have to multiply by 1,000 and 100. So basically, I multiply by 100,000. So here, let's put this here so you understand it. This means that 1 kilometer, when I multiply by 100,000, I will get 100,000 centimeters. Now, centimeter here will be removed with centimeter. Once you have the same units, you can remove them. As we said, first thing you do, you turn them into centimeters. And then after doing this, you just have to remove the centimeter word and then take a look at the numbers. If the numbers in the ratio of 1 to n, you can leave the answer as it is. If they're not 1 to n, you have to make them 1 to n. So basically here I end up with 5 to 100,000, like this. Now, this ratio, is it 1 to n or not? Very good. It's not 1 to n. It means I have to make it 1 to n. How do I make it 1 to n? By making the first number 1. How do we do this? By dividing the number by itself. So because I divided the first number by itself, which is 5, I'm going to do the same for the second number. I'm going to divide it by 5. So basically focus on this. We divide the first by the first number, both of them by the first number to make it 1 to n. This one will become 1. And then 100,000 divide 5 will be 20,000. And this is how I answer a question like this. So to turn them all to a map ratio, first you make them all centimeters, remove the centimeters together, and then make them 1 to n. And this is how I answer a question like this. Now let's move on to the next question. Here we covered this. Same ideas, same ideas. You just use them as centimeters all and find the missing numbers. Now that's it for 8.3. Let's move on to 8.4. In 8.4, we're going to talk about congruent and similar shapes. Congruent and similar shapes. The word congruent means what? It means identical. It means identical. And similar means what? Similar means enlarged shapes. Enlarged shapes. They are the same, but they are enlarged. But congruent means identical. And identical means what? It means all the lines or all the sides are the same. Let's take a look at some of the questions and understand the ideas. First question here. This is very important. This question is very important. It's about scales or scale factor of enlargement. Now, for scale factor of enlargement, we have two shapes here. First, what is the scale factor of enlargement from A to B, A to B, and then from B to E, A, B to A. So basically, these are two different questions because changing the alignment, this means they change the original and the new shape. So from A to B, This makes A original one, original, let's write it here, and makes B the new one. This changes everything and basically changes the scale factor. So that's the original and that's the new. Okay. Now, we talked about this before. We said that the enlargement, or how to find the scale factor of enlargement, the scale equals, let me write it here, the scale equals the new shape divided by the original, or the new side of a shape divided by the original. And both of them must be corresponding sides, origin. So basically, we divide the new shape by the original, like this, to find the scale of enlargement. So here, A to B, it means we take the new, which is B, and divide it by the original, which is A. Now we take a look at the lines here in B. We take this base, for example. This one is 6 centimeters, and this one is 3 centimeters. Now the scale will be 6 divided 3 because B is the new one and 3 is the original one. So we're going to say 6 divided 3, 6 divided 3, and the answer is 2. So the scale factor of enlargement here is 2. Now, when it comes to this question, B to A, this means we changed the place of the original and the new. Now, B became the original, okay, and A became the new one. And to find the scale, I have to divide the new one by the original. So I have to do the opposite now. So the new one here is A, which is 3, so 3, and then divide the original, which is B, and it's 6. So the answer of 3 over 6 is going to be 0.5, or it's going to be half, which is 1 over 2, like this. And this is how you find the scale of enlargement using the shapes that you have in front of you. So focus on the order because the order changes the answer. Now let's move on to the next question. As you can see here, these shapes are enlarged by each other, so they are not congruent. Basically, they are similar because congruent means the same size of lines and the same angles. Now, let's take a look here. These are opposite angles, so they are equal. So A and C are opposite, so they are equal. D and B are opposite, so they are equal. Here, we talked about this before. We said that when we have two parallel lines, it means the letters that make the letter, angles that make the letter Z, they are alternate and they are equal. So C is equal to A and B is equal to D. So basically, if they are alternate, they are equal. And that's the idea of this question. Now, let's move on to the next question. Yeah. Which of these shapes are congruent and which are similar? We talked about being congruent. We said congruent means identical, exactly identical. For example, here we have A, it is 4 by 3, and C is 4 by 3. So A and C are congruent. A and C are congruent. Other congruent shapes, we can say that E and B are congruent because it's 2 by 4, 2 by 4. So these are congruent. So as we said, A and C, A and C, these are congruent. We have B and E. B and E are congruent shapes. So we said that congruent means identical. It means the same number of width and length for these rectangles. And that's the idea of having congruent triangles. Yes. Now, identical triangles or congruent means they have the same sides, as we said. So similar triangles means what? Similar triangles means enlarged by each other, enlarged by each other. Okay? So enlargement means what? It means one of them is smaller than the other, but they have a scale factor of enlargement. It means, for example, line or rectangle, let's use the colors. The rectangle G here, this one has 1 and 2. So it's 1 by 2. When we multiply this by 2, let's say we multiply it by 2, it's going to be 2 by 4. So it will become like E, 2 by 4. This means G and E are similar. I can say that G and E are similar because there is a scale factor of enlargement between them, and this makes them what? This makes them similar. That's the idea of congruent and similar shapes. Now let's move on to the next question. Okay, drawing accurately different triangles, construction here. Now, these are the reasons or the reasons of congruency. And when do we say that these triangles are congruent or not? Congruent or not, okay? Um, let's take a look. Now, let's say this one, uh, triangle A here, okay, has what? It has a side of 3 and 4, and it has an angle. Okay, it has an angle. Now, the reasons of congruency, we have them. At least we need one side to say that these two triangles are congruent to each other. For example, let's take a look at the question here. Here we have two triangles. These two triangles are congruent, and the reasons are what? We have one side which is S, and an angle which is called A, and another side which is S. So when we write it, we will write S, A, S in this order. So it has to be ordered to make sure that you understand the idea of congruency. So we said that SAS means side, angle, side, and this means both of them are congruent. And as we said, you need at least one side to say that these triangles are congruent. Here, this line is the same as this one, 5 is the same as 5, 3 is the same as 3. So all the three sides are the same. So you're going to say SSS, and this is the meaning of congruent triangles. Here, we have three angles and a side. Now, in this question, we can't say AAA because AAA doesn't mean congruent triangles. AAA means similar triangles because triangles can be enlarged but still have the same angles. So I have to mention a side with the angles to make sure that I'm talking about congruent triangles. So, for example, here I can say ASA like this. So I'm going to say ASA to say that these triangles are congruent. And that's the idea of congruent triangles and the reasons of congruent triangles. Now let's move on to the next question. Here, same idea. This is the original one. Now we want to check which one is congruent with this triangle. First, let's take a look at the first one. Here we have 2.7. We have a 3 and a 4.2. This means all the sides are the same. We can say SSS, and this means that these triangles are congruent. Now the next one here, we have 3, we have 4.2, and an angle in the middle. So we can say SAS, and this means that these triangles are congruent. But here we have two things. We have an angle and it's not even mentioned here. But when you do the measurement, it might be right. And then we have a 4.2. But the problem is that we have two information only. We don't know the other lines and we don't know the other angles. This means we can't say that these triangles are congruent. And that's the idea of this question. I hope you understood it. Now let's move on to the next question. Here, let's see. Yes. Next questions will be about similar triangles and how to find out the missing sides. So I'm going to stop the video here. That's it for these congruent triangles. In the next video, we're going to talk about similar triangles and how to use them to solve problems and how to find the missing lines using similar triangles. Thank you very much for watching. See you next time.